Okay, so this is us taking readings with the DMM when we first powered up the solar panel. When it came time to sizing everything up, we had to make sure that we could power everything. We had to know how the timing would be. We had to know how long we could run each device. In the very start, we needed to know what peak current each device had. So, for the most part, it came down to just a lot of calculations and a lot of planning. Here, as you can see, we're getting a reading of, I believe, 19.96 volts off of it, and we're connecting it to the charge controller, kind of get situated with that whole process. As far as power goes, we used Watt's law to determine which devices to use and how long to use them with everything else in the system. Watt's law is power equals current times voltage, or power equals current squared times resistance. So when it came time to decide on each device, we looked at the peak current that it had. And it was kind of a safety net. We chose that current, we took that current and we multiplied it by the voltage, which is 12 volts. By the way, we should mention this is an all DC system. We went with that to avoid having to use an inverter. The problem with that is testing all the devices at home was a bit of a problem. So we did that for each device, and that gave us the power. And so after we got every device's wattage, we added it up. We multiplied that by the amount of hours that we want to use it. So in the end, the total load we would be using was around 990 watt hours, and that was all the wattage times 12 hours. So we're going for the 12-hour a day cycle. So we compare that to the power that our solar panel would produce. It was a 190 watt panel, so we multiply that by 5.5 hours. That's the peak hours in Florida. And we do that because those are the hours that the solar panel is going to be operating at its best. And that's optimal. Realistically, it's never like that because of weather. Obviously, the Sunshine State isn't always the Sunshine State. So we have to take that into account. So to compare those numbers, the total for that cycle ended up being about 1,045 watt hours. So that had us covered for the daytime. The big thing was choosing the batteries after that because they're what we rely on for the nighttime. So we have a 12-hour nighttime cycle. For each battery, we use sealed batteries, deep cycle, they're better for solar. For solar processes, we use 55 amp hour batteries. So what we do is we multiply the amp hours of the batteries, what they're rated at, we multiply that by the voltage, which is 12 volts. So total each battery gave us 660. So we add up the batteries and we ended up getting about 1,300. So that covered us for the nighttime. That's how we were planning it out. It turned out in the end that we would want to add another battery to the system because the more you compensate for future trouble like rain, cloudy days, also high temperatures. High temperatures is bad for solar panels. You want cool temperatures, sunny weather. So that being said, we would have a 3 battery pack, and that's what we run it on. Also, we want to touch on the charge controller because it's very important. It's basically regulating the voltage and or current for the batteries. And if we don't do that, we could actually damage the batteries. Which could be a pretty big problem, but what we want to do is kind of set it and forget it. Be able to set the system, leave it, walk away, and let it automate itself and let the plants grow on their own with the system. So you have to account for everything.